Welcome back to Mr. Slover's Math. Today we're going to focus on normal distribution. So you're going to use the mean and standard deviation to fit into a normal distribution and interpret a normal curve in context. So the warm-up is getting us ready to pretty much graph what we need to. So you're finding the mean or the average. So you're adding your two numbers and dividing by 2. And then the middle number or the median is, since I have two numbers in that set, I add them together and divide by 2. So many common statistics such as human height, weight, blood pressure is gathered from samples in the natural world, and they tend to have a normal distribution about their mean. So data that varies randomly about the mean is our normal distribution. Other types of distribution. So here's my normal distribution, a bell curve. But there are other types. So here's another type of distribution. This one is skewed left. So a lot of my data is over here, and there's not a lot over here. So it means the mean or the average is smaller than the median. So an example is a long jump. Your median is your middle number, remember, and then your mean is the average. So you're saying your average is smaller or less than what your middle number is. The next one is skewed to the right. So you have more data over here. So the mean is larger than the median. An example is basketball salaries, or pretty much any type of major league sport salary. So it's saying the average is larger than the middle number, which if you think about it, does make sense. You have the people that are making hundreds of millions of dollars, and they're the ones that are skewing that data because they're included in that average. And then this one really isn't a pattern or a shape. Like this one had a shape that was curving up that way. This one had a shape curving up that way. So we say that there's no skewedness. So there are other types of distributions, but we are just focusing on this bell curve. And we say that the data is normally distributed when the mean, the median, and mode are approximately equal. Your data values are symmetric, and approximately 50% of the data is before the mean and 50% is after the mean. And that's what our bell curve is. So it says fill out the graph below using the given mean and standard deviations. So my mean is 45, my standard deviation is 5. So going to the right, I'm adding my standard deviation. Going to the left, I'm subtracting. And just like yesterday, the graphs that I'm giving you are going to have this information: mean minus S, mean minus 2SD, mean minus 1 SD, mean plus 1 or plus 2. So that information is going to be there. You just have to make sure you read it and understand what it means. The mean is the average number. I'm telling you that number. You're figuring it out. And then plus 1 standard deviation, plus 1 SD. So now let's put this into perspective. The standard deviation is the measure of how spread out the data is. Within 1 standard deviation is 68% of the data. Within 2 standard deviations is 95% of the data. And that's crazy to think that 95% of the data falls within 2 standard deviations of the mean. It's crazy. And then the last one is 3 standard deviations. So 99.7% of the data falls within 3 standard deviations of the mean. So let's see some examples with this. So 68% of the class grades on a test were between 61 and 74%. Fill out the table, assuming that the data is normally distributed. What are the mean and standard deviation? Hint, how many standard deviations does 68% represent? So just like I said here, always use the hints. Your teacher gives you a hint for a reason. I give you a hint for a reason. Use it. So first we got to find the mean. Well, take our two numbers, add them up, divide by 2. Our mean is 67.5, and right there where it says mean, put 67.5. Standard deviation. Well, if we're looking, it does not say what it is. But we know from the mean to the first number, right, because it says 68%. Well, that's one standard deviation. So one standard deviation, one standard deviation. That's why we're putting those numbers there. Think of a number line. Your smaller numbers are to the left. Your larger numbers are to the right. So that's why 61 is here and 74 is here. So because it says 68%, that's one standard deviation. So that's why I'm putting those numbers there once again. And I need to find out what that standard deviation is. Don't make it complicated. One standard deviation. So all I'm doing is I'm subtracting this number minus this one. And I got 6.5. Done. Okay, don't overcomplicate it. Example 3. 95% of the students at a local junior high weigh between 62 and 90 pounds. What are the mean and standard deviations? So once again, here's a hint. What does 95% of the population or 95% of the data represent? That's 2 standard deviations. So these two numbers are on the 2 standard deviations from the mean. Well, we can find the mean by adding them up and divide by 2. So our mean is 76. Since 95% is 2 standard deviations, the 62 and the 90 go at the 2 standard deviations. But I still want you to find the standard deviation. We didn't find that yet. Okay, we found the mean, and then we found where the mean minus 2 standard deviations is and where the mean plus 2 standard deviations is. So you might be thinking, well, how do we find this number? Well, this is between, right, because this is symmetrical, this is between 62 and 76. So over here, I'm adding 62 and 76. I'm dividing by 2. I'm finding the middle number of 62 and 76. I'm finding the average, if you want to think of that. It's the same thing because it's all symmetrical. Your mean, your median, your mode are all the same. That's why this works. So I find that number, and that's 69, or on the other side, it's 83. It doesn't matter which one. And then we do the same thing we did up here. We did this number minus this number. 83 minus 76. Okay, or in this case, I did 76 minus 69. It doesn't matter which option you go. Example 4. So the Boston Tea Company is packing some tea. Our standard deviation is 2.5. So I already told you what the standard deviation was. I told you what the mean was. I want to know between what 2 weights is 99.7% of the data. Let's go back and think. 99.7% of the data is 3 standard deviations. So I want to know what the third standard deviation is here and here. Well, the good news is I gave you all the information. 255 is your mean. Standard deviation is 2.5. So once again, it's printed out what you're doing, adding 1 standard deviation, adding 2 standard deviations, and so on. Same thing the other way. So I fill in all of these numbers and I answer my question. 99.7% of the packages that are packed, that are made, weigh between 247.5 grams and 262.5 grams. And that's what it's saying here. To you, it may not mean a whole lot, but to that company, it's telling them that 99.7% of their product is between these two weights, which isn't too bad considering that it's a 250 gram tea package that you're creating. Okay, so maybe to have better profits, larger profits, you would want that standard deviation to be even smaller. So that way that company would be more profitable, because it seems like some of them get more than 250 and some of them get less. And then the last one. So very similar to what was up here, but now I want 95% of the students are between what two percentages. So this test had grades that were between 36 and 68%. So 95% of the students scored between 36 and 68%. So think about it. Is that a good test? Nope. Right? If your score is out of 100 and 95% of your students are not even getting a C, something didn't work out. So if you have questions, make sure you reach out and ask. But the big takeaway